Case. The chassis, commonly called the computer case or tower, holds and protects every internal component. It shields them from dust and damage, as well as electrical interference. While it doesn't contribute to computing speed, it plays an important role in airflow and long-term reliability. Cases come in various sizes, each designed to fit specific motherboard formats. Early computers used basic metal enclosures, but today's models are far more advanced, as many now feature tempered glass panels and internal layouts designed for clean cable management and efficient cooling. While cases aren't typically the most expensive component, their prices can range from $30 for basic models to over $200 for premium cases with sound insulation and improved thermal performance. Often overlooked, inadequate airflow or a cramped case design can result in overheating and shorten the lifespan of other components, so choosing the right case isn't just aesthetic, making it more than just a shell. Motherboard. As the core platform inside any computer, this circuit board connects and coordinates all essential computer parts. It acts like the central nervous system that manages data traffic between the CPU, memory, storage, and peripheral devices. Motherboards have evolved dramatically since the early days of personal computers, transforming from basic connector boards into smart hubs. Today's motherboards frequently come with built-in wireless and USB features, along with tools for system customization. It's a mid-price component overall, ranging from under $100 to over $500 depending on features. Every other computer part must match the board's layout, so compatibility is really important. Though often underestimated, the motherboard plays a central role in system performance and future upgrade paths, which makes it one of the most important choices in any PC build. CPU. Responsible for nearly every task your computer performs, the central processing unit, commonly known as the CPU, acts as the system's brain. It executes instructions and manages overall operation. These chips have evolved from single-core designs into powerful multi-core processors capable of handling billions of operations per second. CPUs vary in core and thread count, as well as clock speed. More cores allow better multitasking, while higher clock speeds improve single-threaded performance. Brands like Intel's Core series and Ryzen dominate today's consumer market, offering options for everything from casual browsing to professional content creation. The CPU is generally one of the more expensive components, with prices ranging from $50 to over $1,000 depending on performance and features. While graphic cards handle most visual processing today, the CPU remains critical for system responsiveness and background tasks. Hence, choosing the right CPU will directly affect your system's speed and overall performance. Graphics card. This component is responsible for handling all on-screen visuals. The graphics processing unit, better known as the GPU, manages everything, from game environments to professional visual workflows like 3D modeling or animation. Leading brands like GeForce and Radeon dominate the market today, with models supporting cutting-edge features like ray tracing and 10K resolution rendering, as well as AI-based image enhancements. It's one of the most expensive components in a system, with prices ranging from $100 to over $2,000 depending on performance tier and features. Choosing the right GPU will affect the overall responsiveness in graphics-heavy applications such as games and video editing tools, making it a core component in both creative and high-performance systems. RAM. Acting as the system's short-term memory, random access memory, or RAM, temporarily stores the data the CPU needs to access quickly. This allows the processor to retrieve information much faster than from traditional storage, which significantly improves multitasking and overall responsiveness. Invented in the 1960s, RAM has become essential in modern computing. It's typically measured in gigabytes, and most systems today come between 8 gigabytes and 32 gigabytes. Faster and larger modules can make a noticeable difference in high-demand tasks like video editing or gaming. It's a mid-price component overall, ranging from around $30 to several hundreds, depending on the specifications. Unlike storage drives, RAM is volatile. It loses all data when the system powers off, so it's used only for active processes. Ensuring you have enough RAM is crucial for keeping your system smooth and responsive while handling multiple programs at once. Hard disk. As one of the oldest storage technologies still in use, the hard disk drive, or HDD, stores data magnetically on spinning disks. First introduced by IBM in the 1950s as a large storage device weighing 2,000 pounds, hard disks transformed how computers handle data, steadily increasing in capacity and becoming widely affordable over time. While SSDs are now favored for speed, HDDs continue to serve an important role due to their low cost and massive storage potential. They're ideal for archiving large files and backups, especially in systems where speed isn't the top priority. It's one of the least expensive components, with multi-terabyte drives often available for under $100. Some modern models even include hybrid flash caches to boost performance. Despite the rise of faster alternatives, hard drives remain a practical, cost-effective choice for both personal users and large-scale data centers. SSD. This high-speed storage device offers major improvements over traditional hard drives as it uses flash memory instead of spinning disks. Short for solid-state drives, SSDs provide faster boot times and noticeably improved responsiveness across most tasks, especially in file transfers. These components were introduced commercially in the 1990s and have evolved since then from niche enterprise solutions to everyday consumer essentials, thanks to their dramatic speed and compact size. They're available in multiple form factors, some delivering greater performance by connecting directly to the motherboard. SSDs are moderately priced, typically ranging from $30 to several $100s. Although more expensive per gigabyte than traditional hard drives, the benefits in speed and reliability make SSDs a smart investment, especially for modern systems. These advantages make SSDs essential for anyone who values fast, responsive computing, whether for productivity or general use. Power supply. This component delivers power to every other part of the computer, converting alternate current from the wall into usable direct current for your system. Introduced with the earliest personal computers, power supplies have evolved to offer improved efficiency and safe modular designs. It's a mid-priced computer part, typically ranging from $30 to over $150. Efficiency ratings like 80+ indicate how well it converts energy without waste. Higher rated models produce less heat and provide more stable performance while consuming less energy. Premium units may include modular cables and near-silent operation, ideal for high-end gaming or workstation builds, while a poor quality or underpowered power supply can lead to crashes or even electrical hazards. The power supply unit is a critical investment and plays a direct role in your system's reliability and overall safety. Cooling systems. To maintain safe temperatures and stable performance, modern PCs rely on cooling systems that prevent components from overheating. High-performance processors and graphics cards generate a lot of heat, especially during gaming and multitasking, and without proper cooling, the system can throttle or even sustain hardware damage. The most common method is air cooling, which uses heat sinks and fans to dissipate heat. These fans bring in cool air and push out hot air through case vents. For more demanding builds, liquid cooling is often preferred as it provides greater thermal efficiency and often quieter operation by circulating coolant through a pump and radiator. These setups can be all-in-one units or fully custom loops tailored for enthusiast systems. Cooling isn't just functional, it's a visual highlight in many custom builds, featuring RGB lighting and sleek tubing. Prices range from $20 for basic air coolers to over $300 for high-end liquid systems, depending on complexity and features. Wi-Fi card. Most desktop PCs use a dedicated network card or USB Wi-Fi adapter to connect wirelessly without an Ethernet cable. While many modern motherboards include built-in wireless support, these add-on cards remain common for older or budget systems. These cards include antennas that receive signals from your router and convert them into usable data, while some also support Bluetooth, offering extra connectivity for wireless peripherals. As home networks advanced, these cards evolved too, now supporting high-speed protocols. It's one of the most affordable components, ranging from $15 to over $70 depending on speed and features. In essence, a wireless card removes the need for Ethernet, giving you flexibility to position your PC wherever you want without sacrificing internet access or signal quality. Output devices. When your computer processes data, it needs a way to present the results, whether that's visually, audibly, or even physically. That's where output devices come in. The most common example is the monitor, which displays everything from websites to video playback. Speakers and headphones turn audio signals into sound, while printers produce physical copies of digital files. Other output devices include projectors and VR headsets, which extend how we see and interact with content. Over time, these devices have improved. For example, monitors have evolved from bulky components into slim, high-resolution displays that support 4K and HDR. Similarly, audio gear has upgraded from basic mono speakers to immersive surround sound systems and noise-canceling headphones. These devices vary in price. For example, monitors can range from $80 to over $1,500, and audio devices from under $20 to premium-grade levels. A weak display or poor audio setup can seriously impact your overall experience, no matter how powerful the PC is. Input devices. Every interaction you have with a computer starts with an input device. The most essential are the keyboard and mouse, wherein the keyboard handles typing and commands, while the mouse gives you precision for navigation and control. Keyboards range from basic membrane models to premium mechanical boards. Mice vary widely too, from ergonomic designs to high DPI gaming models with programmable buttons. Other input methods include trackpads, game controllers, drawing tablets, and microphones. Touchscreens combine both input and output in a single surface, now common in laptops and tablets. These devices have come a long way, from early punch cards and command line terminals to the intuitive, responsive peripherals we rely on today. They're generally affordable, ranging from $10 to over $200. Ultimately, input devices shape how effectively and comfortably you can use your computer, especially over long sessions. Thus, they are essential for productivity and seamless interaction. And that wraps up our breakdown of every major computer component. If this helped you understand your PC better, give it a like, hit subscribe for more tech explainers, and ring the bell so you're first to know when the next video drops.